The physics of four-ling cats. In the 1980s, a series of photographs taken by the physiologist Etienne Jules Mary sent his fellow scientists into a tizzy. His photographs seemed to capture an event that violated the laws of physics. Namely, a cat that had managed to twist in midair and land on its feet after being dropped. Humans have long been amused and impressed by cats' preternatural ability to land on their feet. But physicists had assumed that this was only possible for cats that launched themselves off of a surface. While impressive, this feat would still follow a major law in physics known as the conservation of angular momentum. This idea states that bodies that aren't rotating cannot start rotating without first applying some external force, like launching off a surface. A dropped cat would have no such leverage. And without that external force, it shouldn't be able to right itself. And yet, Mary's cat had. Today, we know that this righting reflex doesn't actually defy physics. There is a condition that allows angular momentum to be conserved within a spinning object when the two halves of that object are rotating in opposite directions. Consider a pepper grinder. When you twist a pepper grinder, the two halves exert an equal, opposite, and twisty force on each other. Angular momentum is conserved. This appears to be the same loophole four-ling cats exploit. Cat skeletons are so flexible that they can effectively split a cat's body into halves. To twist in midair, the front half usually flips first. Cats accomplish this by tucking their forepaws in while keeping their back limbs splayed out. This movement allows cats' front halves to move faster than their back halves. The cat then yanks in its back legs while simultaneously relaxing its front limbs. This motion creates the twist that brings the cat right side up again. This righting reflex begins within a fraction of a second, and for even speedier spins, cats may use their tails as propellers. The main ideas. Dropped cats can twist in midair to land on their feet, seemingly defying the law of conservation of angular momentum. Angular momentum can be preserved within a spinning object if its two halves rotate in opposite directions.